So solubility of an inorganic salt, we can easily simply define that as the amount of that solid. It's normally given in either moles or mass. It's the amount of that solid that will dissolve in a litre of solvent at a given temperature. Okay, thinking about that in terms of energy, the dissolution of that material occurs when the free energy required to disrupt the lattice bonding is offset by the free energy released in the formation of aqueous species. What do we mean by that? So we've got our free energy required to disrupt our crystal lattice. So if we imagine our crystal lattice here with all the atoms or ions lined up nicely in an ordered way, to break that lattice apart, to free those ions or atoms to float around dissolved in solution, actually costs energy. Okay, so you've got your favourable lattice energy, which is holding all those atoms and ions together in that lattice. Okay, and you've got to basically disrupt that to free those ions or atoms to float around in solution. Okay, so balanced against that, so that's a cost of energy, that's energy required. Balanced against that is the energy released in the formation of aqueous species. Okay, and we can talk about what we mean in terms of aqueous species if we look at this equation below. So we're basically expressing this same seesaw as in the form of an equation. Okay, so we've got our overall free energy of solution, we've got our free energy required to disrupt the lattice bonding, that one links to the one up there, and then if we think about the free energy released on formation of aqueous species, what we mean by that is three different things. Okay, so we've got our delta GH, that's our free energy released in the formation of hydrated iron, so that's where you've got your iron bound to H2O molecules in the solution. We've got ion pairs, so that's where you've got the ions interacting with other ions within that solution, tends to be more at high concentration, or complexes. Okay, so if you imagine in a biological solution, you're going to have all sorts of organic molecules floating around, things like enzymes or proteins or even smaller molecules, and those are going to interact with your metal ions from your crystal lattice that have dissolved into that solution. Okay, we're going to bind to them essentially as ligands. Okay, so all of those things are going to contribute to an energy release, and that's balanced against that energy required to disrupt that crystal lattice. Okay, and when this side is higher than that side, then we get dissolution of the solid.